Hello and welcome to Lucid Mind Chemistry channel with Majid. In this video, I'll be solving Chemistry O-Levels Multiple Choice, Paper 11 from May-Jun 2019. You can go to any particular question by following timestamps given in the video description. Let's start. Question 1. An experiment is done to measure the rate of reaction between calcium carbonate and dilute hydrochloric acid. The gas formed is collected in a gas syringe. Which additional pieces of apparatus are essential to measure how the rate of reaction changes with temperature and the amount of acid used? First thing is the apparatus to measure temperature. Second thing is the apparatus to measure amount of acid used. Now temperature can only be measured by thermometer, it cannot be measured by balance or measuring cylinder, so therefore it could be either C or D. The apparatus to measure the amount of acid cannot be condenser, it can only be measuring cylinder, as measuring cylinder is used to find out the volume while condenser is used to condense vapors back into the liquid state. Correct answer is therefore D. Question number 2. After acidification with dilute nitric acid, a colorless solution of X reacts with aqueous silver nitrate to give a white precipitate. What could X be? Now this is anion identification test. And in this test what happens that silver ion from silver nitrate reacts with halide from given salt to form precipitate. Let's see which one gives out white precipitate. First one is calcium iodide. So when calcium iodide is put in aqueous silver nitrate in the presence of nitric acid, the precipitate that is formed is silver iodide. And silver iodide is yellow in color. We need a white precipitate, so therefore A is incorrect. B is copper 2 chloride. Now copper chloride solution is actually pale blue in color. While in the question they had given that the solution of X is colorless. So it means it is not copper chloride. So B is also incorrect. C is lead 2 iodide. The formula is PbI2. It can react with silver nitrate in the presence of nitric acid. To form silver iodide. Again, silver iodide precipitate is solid and it is yellow in color. So C is also incorrect. D is sodium chloride. Now sodium chloride is colorless solution and it can react with silver nitrate in the presence of nitric acid to form silver chloride. Now silver chloride precipitate is white in color. Therefore, sodium chloride is correct. The answer is therefore D. Question 3. A paper chromatography experiment is carried out to separate and identify the mixture of amino acids produced from the hydrolysis of protein. Which apparatus is needed? For paper chromatography, we need chromatography paper, and as amino acids are invisible, so therefore in order to make them visible we would need locating agent for amino acids. Third thing in part A is marker pen. We are not going to use pen because pen is made up of inks and inks can also be separated by using paper chromatography. We only need the result of amino acids, so therefore instead of pen, pencil can be used. We can draw a baseline by using pencil, and we can use ruler to measure the distance traveled by the solvent and the distance traveled by solute. We are also going to use solvent because solvent will be used to separate the mixture of amino acids. However, thermometer is not needed because we are not measuring the temperature, only separation is taking place. Correct answer is therefore B. Question 4. Which conditions will give the highest rate of diffusion of a gas? First thing is the molecular mass of gas, second thing is the temperature. Now we know that rate of diffusion is directly proportional to temperature because temperature increases kinetic energy of the molecules, and when kinetic energy becomes high, diffusion also takes place faster. It means that at higher temperature, highest rate of diffusion will take place. Second thing is molecular mass. Now rate of diffusion is always inversely proportional to the molecular mass of gas. This is because lighter the gas, faster will be the rate of diffusion as molecular mass will be low. So we need small molecular mass for faster diffusion. Answer is therefore C. Question 5. Cobalt is a transition element. A particle of cobalt contains 24 electrons and has a nucleon number of 60. Which statement about this particle is correct? Now, according to the periodic table, the atomic number of cobalt is given as 27. Nucleon number is already stated, it is 60. Now, if atomic number is 27, it means number of protons is 27. In neutral cobalt, number of protons is equal to the number of electrons, but they have given 24 electrons. It means 3 electrons are less than protons. It means 3 electrons are lost. So the charge on cobalt should be plus 3. In order to find the number of neutrons, we have to subtract 60 with 27. So neutrons equals 60 minus 27. Which equals 33 neutrons. Let's look into the options. A, it is a plus 3 ion or 3 plus ion. This is correct because 3 electrons are lost. It is a negative 3 ion. This is wrong. It contains 24 neutrons. This is incorrect. It contains 24 protons. This is also incorrect. Answer is therefore A. Question 6. Diamond and graphite are two different forms of the element carbon. They have different uses. Which row is correct? First use is to cut glass. As we know that graphite is slippery while diamond is a very hard substance. So diamond can be used to cut glass while graphite cannot be used. Second thing is use as an electrode. Now diamond is a bad conductor because it does not have any free electrons, while graphite is a good conductor as it contains free electrons, so therefore graphite can be used as an electrode in electrolysis. Now third use is as a lubricant. What happens in graphite is that between the layers weak intermolecular forces of attraction are present. So due to these weak intermolecular forces, the layers can slide over each other, so therefore graphite can be used as a lubricant. Correct answer is therefore B. Question number 7. Which diagram shows the outer electron arrangement in calcium fluoride? Now calcium fluoride consists of two elements. One is calcium and the second is fluorine. Calcium is a metal as it belongs to group 2 of the periodic table, and it has 2 electrons in the outermost shell. While fluorine is in group 7 of the periodic table, so it is a non-metal, and there are 7 electrons in the outermost shell of fluorine atom. Now we know that the bonding between metal and non-metal is called ionic bond, and in ionic bond, metal loses electron while non-metals gain electron. So therefore calcium will lose its 2 electrons that are present in the outermost shell to form calcium positive 2, and the inner shell is already complete. Two electrons are lost in the process. As 2 electrons are lost and one fluorine atom can only gain 1 electron to complete 8 electrons in the outer shell, so therefore we will need 2 fluorine atoms to bond with 1 calcium. There are 7 electrons in one fluorine atom, and each fluorine atom will gain 1 electron, so therefore for 2 fluorine atoms there will be 2 electrons gained to form 2 fluoride ions. The 8th electron will be of calcium. As fluorine has gained electrons, so therefore now it has become negatively charged. Let's look into the options. In A, we can see that the electrons are shared between calcium and fluorine, which is incorrect because sharing takes place in covalent bond, while in calcium fluoride ionic bond is present. Similarly, in B, we can see that the sharing of electrons has taken place, which is also incorrect. In C, we can see that calcium has lost 2 electrons to form positive 2 ion, while each fluorine has gained 1 electron to form negative ion. So therefore C seems to be correct option. In D, we can see that calcium has gained electron to form negative 2 ion, which is incorrect because calcium is a metal and it loses electron to form positive ion. The correct answer is therefore C. Question 8. What is the number of shared pairs of electrons in an ammonia molecule? The formula of ammonia is NH3. Now nitrogen is from 5th group in the periodic table. It means it has 5 electrons in the outermost shell. As it needs 3 electrons, so therefore it will make 3 single covalent bonds with 3 hydrogen atoms. Each hydrogen atom shares 1 electron with 1 nitrogen. So the bond formed are like this. Now in the question it asks that how many shared pairs of electrons are present. Now this is a shared pair of electron. This is also a shared pair. Similarly this one. And this is not a shared pair, it is a lone pair of electron. So we can see only 3 shared pairs of electrons are present. The answer is therefore A. Question number 9. 2 statements about metals are given. One is that metals contain a lattice of negative ions in a sea of electrons. Second is the electrical conductivity of metals is relative to the mobility of the electrons in the structure, which is correct. Now in first statement they have given that metals contain a lattice of negative ions in a sea of electrons. This is incorrect because metals contain a lattice of positive ions in a sea of electrons. This is because metals always lose electron to form positive ions. Statement 1 is therefore incorrect. In statement 2 they have given that electrical conductivity is related to the mobility of electrons in the structure. This is true because metals conduct electricity because of the presence of mobile electrons. So therefore statement 2 is correct and statement 1 is incorrect. The answer is therefore D. Question number 10. Powdered calcium carbonate reacts with dilute hydrochloric acid to produce calcium chloride, water and carbon dioxide. What is the correct ionic equation including state symbols for this reaction? Let's write equation for this reaction. We have calcium carbonate, which is solid. It reacts with HCl, which is aqueous, to form calcium chloride, which is aqueous because it is a soluble salt, water, liquid, and carbon dioxide gas. Let's balance this equation. We have 2 chlorine atoms on the product side, so we can write 2 with HCl. Now hydrogen atoms are balanced, chlorines are also balanced, calcium is already balanced, and CO3 is already balanced. Now for writing ionic equation, we have to convert aqueous parts into its respective ions, while solid, liquid and gas are not converted into ions. So rewriting this equation, we can write calcium carbonate solid. HCl will be converted into its ions, which is H positive, Cl negative. Again, calcium chloride is written in the form of ions, which is calcium plus 2 aqueous, and as there are 2 chlorines, so 2 chloride ions will be formed. Water and carbon dioxide will be written as it is. Now let's find out the spectator ions, which are the ones that are present both on the reactant and product side unchanged. Now writing the ones that are left behind, we have calcium carbonate solid plus 2H plus aqueous, which forms calcium plus 2 aqueous plus H2O liquid plus CO2 gas. Now this is the ionic equation for this reaction. As we can see that in D we have calcium carbonate solid, then 2H plus aqueous, then calcium plus 2 aqueous, water in liquid form and carbon dioxide in gaseous form. So therefore D is the correct answer. Question 11. In a volumetric experiment, 25 cm cube of 0.1 mole per decimeter cube sodium hydroxide reacts exactly with 20 cm cube of sulfuric acid. This is the balanced chemical equation in which 2 moles of sodium hydroxide react with 1 mole of sulfuric acid to form salt and water. What is the concentration of the sulfuric acid? Now the formula of concentration is number of moles divided by volume in decimeter cube. We have the volume given, but we do not have any number of moles, so let's find the number of moles first. Formula of concentration in mole per decimeter cube is number of moles divided by volume in decimeter cube. Now we have volume in centimeter cube. We can convert it into decimeter cube by dividing by 1000. So it becomes 0.025 decimeter cube. For number of moles, we can rearrange this formula. Number of moles is equal to concentration into volume in decimeter cube. Concentration is given, which is 0.1 mole per decimeter cube. Volume is 0.025 decimeter cube. Now number of moles come equal to 0.0025 moles. This is the moles of sodium hydroxide that are present in this volume and in this concentration. Now according to the balanced chemical equation, we have sodium hydroxide and sulfuric acid. 2 moles of sodium hydroxide react completely with 1 mole of sulfuric acid. Now we have this much moles of sodium hydroxide, so therefore it will react with X moles of sulfuric acid. Now let's cross multiply to find the moles of sulfuric acid that react completely with 0.0025 moles of sodium hydroxide. So we can write X equals 0.0025 into 1 divided by 2. So the answer is 0.00125 moles of H2SO4. Now finally we have the moles of sulfuric acid. We also have the volume in centimeter cube, which can be converted into decimeter cube by dividing by 1000. So it comes equal to 0.020 decimeter cube. Now again we can use the formula for concentration. Concentration is equal to number of moles divided by volume in decimeter cube. Number of moles is 0.00125, while volume in decimeter cube is 0.020. So the concentration in mole per decimeter cube comes equal to 0.0625 mole per decimeter cube. The answer is therefore A. Question 12. The reaction for the conversion of bromoethane to ethanol is shown. This is the reaction in which bromoethane converts into ethanol by reaction with sodium hydroxide. Now OH displaces Br and Br is left out with sodium. In an experiment, 10.90 grams of bromoethane is converted into 3.45 grams of ethanol. What is the percentage yield of ethanol? Molecular masses are given. For C2H5Br it is 109, for C2H5OH it is 46. Now the formula percentage yield is equal to actual yield divided by theoretical yield into 100. Actual yield is the one that can be found through experiment, and actual yield is always given in the question. In this question, 3.45 grams of ethanol is the actual yield, while theoretical yield is to be found out by using calculations using balanced equation. In this question, we have two things. One is bromoethane and second is ethanol. Now the mass of bromoethane is given. It is 10.90 grams, and molecular mass is also given. So we can find out the number of moles, as moles is equal to mass in grams divided by molecular mass. So it will be 10.90 grams divided by 109. Now the number of moles come equal to 0.1 moles of bromoethane. We have bromoethane, which is C2H5Br, and we have ethanol, C2H5OH. Now according to balanced equation, 1 mole of C2H5Br reacts to form 1 mole of C2H5OH. So the mole ratio is 1 to 1. Now we have 0.1 moles of bromoethane. So 0.1 moles of bromoethane will form X moles of C2H5OH. By cross multiplying, we can find out the value of X. So the number of moles of ethanol formed is 0.1 mole. As actual yield is given in grams, so theoretical yield must also be in grams. Let's convert these moles into grams. The formula is mass in grams is equal to number of moles into molecular mass. Now number of moles of C2H5OH is 0.1, while the molecular mass is given in the question, which is 46. So now the mass of C2H5OH is 4.6 grams. This mass is the theoretical yield that is formed by chemical calculations. Now putting values in percentage yield is equal to actual yield, which is 3.45 grams of ethanol, divided by theoretical yield, which we have just found out, 4.6 grams, into 100. It comes equal to 75%. The answer is therefore C. Question 13. 1 mole of sugar, which is CH2O6, is burned. Which volume of oxygen measured at room temperature and pressure is required for complete combustion of sugar? The formula of sugar is given as CH2O6. So we can open this formula. We have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Now we can write the equation for complete combustion of this glucose molecule or 1 mole of sugar. C6H12O6. It combusts in the presence of oxygen to form carbon dioxide and water. Let's balance this equation. We have 6 carbon atoms, so we can balance carbon atoms by writing 6 on the product side. Now carbons is balanced. Now we can balance hydrogen atoms. We have 12 hydrogen atoms on the right hand side, so we can write 6 with H2O to make it 12. Now on the right hand side we already have 6 oxygen atoms, while on the product side we have 12 oxygen on this side and 6 oxygen atoms on this side. So in total we have 18 oxygen atoms on the product. So now we would need 12 more oxygen atoms with 6, so we can write 6 with O2 to make it 12. So 12 oxygen plus 6 oxygen, it will also become 18 oxygen atoms. Now equation is balanced, and in balanced equation we can see that 1 mole of this sugar, it needs 6 moles of oxygen for complete combustion. Now we can convert these moles into volume by using formula. Volume in decimeter cube is equal to number of moles of gas into 24 decimeter cube. So as we have 6 moles, 6 into 24, it comes equal to 144 decimeter cube of oxygen. So this much volume is needed for complete combustion of 1 mole of this sugar. So therefore answer is C. Question 14, which statement about purification of copper by electrolysis is correct? In purification of copper, the experiment is set up as this. We have impure copper as anode. Cathode is made up of pure copper. Anode is connected with the positive terminal of battery, while cathode is connected with the negative terminal of battery. The solution is electrolyte, which is a soluble solution of copper. So we can use copper sulfate or any soluble copper salt. So the solution will consist of copper ions and soluble sulfate ions. A pure copper anode is used. Now this is incorrect because copper cathode is pure. B, a pure copper cathode is used. As we can see that pure copper cathode was used in the experiment, so B is correct. C, the color of electrolyte is this solution, fades throughout the process. As in the solution we can see that copper plus 2 ions are still present, so therefore the color does not fade after the chemical reaction or throughout the process, so this is incorrect. Part D, the electrolyte used is a solution of copper oxide in water. Now we can only use that salt of copper that is soluble in water, as copper oxide is metal oxide and it is insoluble in water, so therefore it cannot be used as electrolyte. Correct answer is therefore B. Question 15, which negative ions are present in aqueous copper 2 sulfate? Now in copper 2 sulfate aqueous we have copper plus 2, H plus ions from water, sulfate ions from copper sulfate, and hydroxide ions from water. So the negative ions present are sulfate and hydroxide. The answer is therefore C. Question 16. The diagram shows the energy profile of a chemical reaction. This is the reactants and these are the products. On y-axis we have energy and on x-axis we have progress of reaction. Which statement about this reaction is correct? In the statements we have two things. One is whether the reaction is endothermic or exothermic, and second is what is the activation energy. From energy profile we can see that the energy of the reactant is less than the energy of the product, which is higher. So it means reactants have absorbed energy in order to convert into products, so therefore this is endothermic chemical reaction. Second thing is the activation energy. Activation energy is the amount of energy that is required by the reactants to go into the transition state. So this is the activation energy and it will be equal to P minus R. Let's look into the options. A, it is endothermic. This is correct, and the activation energy is P minus Q. This is wrong. B, it is endothermic and the activation energy is P minus R. This is a correct statement. In C, it says it is exothermic. In D, again it says it is exothermic chemical reaction. So correct answer is part B. Question 17. The table shows the energy released by the complete combustion of some compounds. Which compound releases the least energy when 1 gram is completely burned? Now this energy is for kilojoules per mole, so it is per mole of substance. As we know that 1 mole of a substance is equal to its molecular mass in grams. So we can see that for benzene the molecular mass is 78, so for 1 mole it will be equal to 78 grams. Similarly for heptane we have 100 mR, so for 1 mole it will be equal to 100 grams. Similarly it will be 114 grams for octane and 44 grams for propane. Now let's find out energy per grams. As we have 3270 which is released by 78 grams, so for 1 gram it will be equal to 3270 divided by 78, which is equal to 41.92 kilojoules per gram. Similarly for second one we can find out energy per gram by dividing 4800 with 100, which comes equal to 48 kilojoules per grams. Similarly for third one, 5510 divided by 114, which comes equal to 48.33 kilojoules per gram. For the last one we have 2200 divided by 44, which is equal to 50 kilojoules per grams. As this is all the energy release, so therefore the energy release is always given in negative sign. So we can see that the least energy is given by benzene, which is 41.92 kilojoules per grams. Therefore answer is A. Question 18. 3 experiments are carried out in which the same mass of magnesium is reacted with the same volume of dilute sulfuric acid at room temperature. The magnesium is in excess. In experiment 1 we have large pieces of magnesium, in experiment 2 we have small pieces of magnesium, and in experiment 3 we have large pieces of magnesium and concentration of acid is also increased. These are the graph results. We have W, X and Y. This shows the volume of gas produced in centimeter cube, while on x-axis we have time in seconds. Which row is correct? We have to find out whether which one is experiment 1, which one is experiment 2 and which one is experiment 3 among W, X and Y. According to this reaction, we can see that magnesium reacts with sulfuric acid to form salt, which is magnesium sulfate, along with hydrogen gas, which is shown in this graph. As in the question, we can see that same mass of magnesium was reacted in all three experiments and magnesium is in excess. So it means sulfuric acid is the limiting reagent. And the product always depends on the concentration of limiting reagent. It does not depend on the mass of excess reagent. So we can see if sulfuric acid concentration is high, the volume of hydrogen will also be more. And if the concentration of sulfuric acid is low, the volume of hydrogen will be low. In the graph, we can see that in experiment W, the volume of hydrogen is highest. This is because the concentration of sulfuric acid is more. So as we can see that in experiment 3, the concentration of acid was increased. So it means it is experiment number 3. In experiment 1 and 2, we can see same volume of dilute sulfuric acid at room temperature was used. So it means same volume of hydrogen gas is produced in both. But in experiment 1, large pieces of magnesium were used, and in experiment 2, small pieces of magnesium are used. So small pieces means greater surface area, and greater surface area means faster chemical reaction. So faster chemical reaction can be found out by looking at the graph. The one that is steep will be faster and the one that will be less steep is slower. So it means experiment 2 is X, while experiment 1 is Y. So experiment 1 is Y, experiment 2 is X, and experiment 3 is W. The answer is therefore D. Question 19. The equations show 4 reversible reactions. For which reaction would the equilibrium move to the right for both an increase in pressure and an increase in temperature? In all 4 options, we can see that all reactants and products are gaseous state. Now for equilibrium reaction, if the number of moles of reactant is more than the number of moles of product, so increase in pressure will move the equilibrium to the right. Increase in pressure always move the equilibrium from more number of moles to less number of moles. Let's find the number of moles. In A, we can see that we have 2 reactants, each one is having 1 mole. So in total we have 2 mole of reactant, which forms 2 moles of product. So as the moles of reactant is equal to the mole of product, so therefore increase in pressure would have no effect on the equilibrium. So A is incorrect. In B, we can see we have 4 plus 6, 10 moles on the reactant sides, and 4 plus 5 is 9 moles on the product side. So increase in pressure will move the reaction in forward direction from more number of moles to less number of moles. So this is true for increase in pressure. In C, we have 1 mole of reactant and we have 2 moles of products, 1 each. So by increase in pressure, the equilibrium will move in the backward direction from more number of moles to less number of moles. So this is wrong. In part D, we have 3 moles on the reactant side, 2 of SO3 and 1 of oxygen, while 2 moles are present on the product side. So therefore increase in pressure will make the equilibrium move to the right side. So this is also correct. Now second thing is the increase in temperature. For temperature, you should remember that temperature affects exo and endo in a different way. If the reaction is exothermic, so then increase in temperature will move the equilibrium to the left side. While for endothermic reaction, increase in temperature will make the equilibrium move to the right. This is because in endothermic reaction, temperature is absorbed by the reactants to convert into products. So therefore, increase in temperature will lead to forward reaction and more product is formed. So for equilibrium to move to the right, the reaction should be endothermic, not exothermic. Correct answer is therefore B. Question 20. Gas X turns acidified potassium manganate from purple to colorless. Gas Y turns aqueous potassium iodide from colorless to brown. What do these observations show about gas X and gas Y? Potassium manganate is KMnO4 and it is oxidizing agent. It oxidizes other and itself is reduced. And when it is reduced, it changes from purple to colorless. So as KMnO4 is changing from purple to colorless, it means gas X has reduced potassium manganate and itself gas X has been oxidized. So gas X is a reducing agent. Second thing is potassium iodide. Potassium iodide is used as a reducing agent. It reduces other compounds and itself it gets oxidized. When it is oxidized, it changes from colorless to brown. It means that gas Y, which has turned it from colorless to brown, is a oxidizing agent, as gas Y has oxidized potassium iodide and potassium iodide has reduced gas Y. Correct answer is therefore C. Question 21. Why is ethanoic acid described as a weak acid? Now, weak acid is the one that is less dissociated into its ions upon dissolution. A. It is an organic acid. Now this is a true statement because ethanoic acid is an organic acid, but all organic acids are not weak acids, so therefore A is incorrect. B. It is a poor conductor of electricity. Now this is also incorrect because weak acid can be dissociated into its ions, so therefore it can conduct electricity in aqueous solution. C. It is only slightly dissociated in water. This is true because weak acid is the one that have less dissociation into its ions. D. It reacts only with very reactive metals. This is incorrect because it can react with less reactive metals such as zinc, iron, etc. The reaction will be slow, but it will eventually react. Correct answer is therefore C. Question 22. What is the best method used to prepare a pure sample of copper to sulfate? In A, we have add copper to aqueous zinc sulfate. Now we know that copper is below zinc in reactivity series. So therefore displacement reaction will not occur as copper is unable to displace zinc. Part B is add copper to dilute sulfuric acid. As copper is below in reactivity series, so it does not react with dilute sulfuric acid to form any salt. In part C, we have to add copper 2 carbonate to aqueous sodium sulfate. Now this is copper carbonate and this is sodium sulfate. The product formed will be sodium carbonate and copper sulfate. Now both sodium carbonate and copper sulfate are soluble salts, so therefore it will be difficult to produce pure sample of copper sulfate as both are aqueous solutions. Part D, add copper oxide to dilute sulfuric acid. Now copper oxide is an insoluble solid and sulfuric acid is an aqueous solution, so the reaction will be like this. Copper oxide can react with dilute sulfuric acid to form salt in acid-base reaction. Salt is copper sulfate and second product is water. So as water is not contaminating copper sulfate, so therefore copper sulfate solution can be purified to form crystals. Also we can use copper oxide in excess so that sulfuric acid does not remain, and excess of copper oxide can be removed by filtration process, so we can obtain pure copper sulfate. Correct answer is therefore D. Question 23. What is the percentage by mass of nitrogen in ammonium nitrate? The formula of compound is NH4NO3. Let's find out the molecular mass of NH4NO3. We have 2 nitrogen atoms. For 1 nitrogen, the atomic mass is 14, so for 2 it will be 28. We have 4 hydrogen atoms. So 4 into 1. We have 3 oxygen atoms. So it will be 3 into 16. The molecular mass of ammonium nitrate comes equal to 80. So now the molecular mass of ammonium nitrate is 80. So we can say that in 80 grams per mole of ammonium nitrate, we have 28 grams per mole of nitrogen. We also have 4 grams per mole of hydrogen and 48 grams per mole of oxygen, but they are not needed as we are going to find the percentage by mass of nitrogen only. Now by using formula of percentage by mass, so percentage by mass of nitrogen is equal to mass of nitrogen in 1 mole of ammonium nitrate divided by total mass of ammonium nitrate into 100. Now by putting values, we have 28 grams per mole of nitrogen divided by 80 grams per mole of ammonium nitrate. So the percentage come equal to 35%. The answer is therefore D. Question 24. A student makes 3 suggestions about the Haber's process and the contact process. Number 1. Only one process using a raw material obtained by fractional distillation of air. Number 2. Only one process involves the use of a catalyst. Number 3. The product of each catalyzed reaction has the formula of the type XY3. Which suggestions are correct? Let's find out the raw materials for both processes. In Haber's process, we have nitrogen and hydrogen that reacts to form ammonia gas. In contact process, we have different steps. Sulfur reacts with oxygen to form sulfur dioxide. Sulfur dioxide reacts further with oxygen in a reversible reaction to form sulfur trioxide. Sulfur trioxide is then dissolved in sulfuric acid to form oleum, which is H2S2O7, and in the last step, oleum is diluted with water to form sulfuric acid. Now we can see that the reactants used in formation of ammonia is nitrogen and nitrogen comes from fractional distillation of air. While in sulfuric acid we can see that only oxygen gas is present and it is not obtained from fractional distillation. So statement 1 is correct, as only Haber's process uses raw material from fractional distillation of air. Part 2 is that only one process involves the use of catalyst. We can see that the catalyst used in the formation of ammonia is iron in powder form, while the catalyst used in the formation of sulfuric acid in this reaction is vanadium pentaoxide, which is V2O5. So both processes use catalyst, so therefore statement 2 is wrong. Number 3, the product of each catalyzed reaction has the formula of the type XY3. Now this is catalyzed reaction and the product is XY3, and we have this catalyzed reaction in Haber's process and we have XY3 type formula. So statement 3 is correct, as 1 and 3 both are correct, so therefore answer is B. Question 25, which uses for sulfuric acid are correct? Number 1, as a bleach in the manufacture of wood pulp for paper. This is incorrect because chlorine is used as a bleaching agent. Number 2, as a food preservative in tinned foods. This is also incorrect because sulfur dioxide gas or sulfur trioxide gas is used as a food preservative instead of sulfuric acid. 3, as a raw material in the manufacture of detergents. This is true because sulfuric acid can be used to make detergents. 4, as a fertilizer. Now sulfuric acid is not directly used as a fertilizer, it is used for the manufacture of different fertilizers. As only option 3 is correct, so therefore answer is D. Question 26, element X forms a covalent compound H2X. It forms an ionic compound Na2X. It also forms oxides XO2 and XO3. To which group of the periodic table does X belong? From first, we can observe that a covalent compound is formed. It means X is a non-metal, as only non-metals make covalent compound. From second statement, we can see that 2 sodium atoms are required to react with 1 X to form an ionic compound. As 1 sodium atom loses 1 electron, so 2 sodium atoms will lose 2 electrons and X will gain those 2 electrons to complete its outermost shell. It means X has 6 electrons in the outermost shell and it needs 2 more electrons to complete. So if it has 6 electrons in the valence shell, it is from group 6 of the periodic table. From third statement, we can see that it forms oxides XO2 and XO3. So in group 6, we have sulfur. Sulfur can make SO2. It can also make SO3. So we can say that the group is 6. Question 27. Which property is common to calcium 40, potassium 39 and sodium 23? A. Their atoms all have more neutrons than protons. Let's find out the number of protons from periodic table. Atomic number of calcium is 20. For potassium it is 19 and for sodium it is 11. So in calcium the number of neutron will be equal to nucleon number which is 40 minus atomic number which is 20. So there are 20 neutrons in calcium. Similarly for potassium, the number of neutrons is equal to 39 minus 19 which is equal to 20. And for sodium, it is equal to 23 minus 11 which is equal to 12. As in calcium, the number of neutrons and protons is equal, so therefore statement A is incorrect. B, their ions all have 8 electrons in their outer shell. Now we can do electronic configuration for calcium. Calcium is in second group of the periodic table. It has 2 electrons in the first shell, 8 in the second shell, 8 in the third shell, and 2 electrons are present in the outermost or valence shell. Now calcium will lose 2 electrons as it is present in second group. So it will make calcium plus 2 ion whose electronic configuration will be 2, 8, 8. Similarly for potassium, we have 2 in the first shell, 8 in the second shell, 8 in the third shell, and 1 in the fourth shell. As it belongs to group 1 of the periodic table, so it will lose 1 electron and the electronic configuration left behind will be 2, 8, 8. Similarly for sodium 11, we have 2 electrons in the first shell, 8 in the second shell, and 1 in the third shell. So as it belongs to group 1, so it will lose 1 electron and the electronic configuration left will be 2, 8. As we can see that 8 electrons are left in the ions of all these 3, so therefore statement B is correct. C, they all sink when added to water. This is incorrect because they float when they are added to water. D, they are all deposited at the positive electrode when their molten chloride is electrolyzed. As these are all metals, so metals are cations, and cations move towards negative electrode which is cathode, so therefore this statement is wrong. Correct answer is therefore B. Question 28. Palladium is an element. Atomic number is 46. Some of its properties and properties of its compounds can be predicted from its position in the periodic table. Which row is correct? First is the predicted property of palladium and second is the predicted property of palladium compounds. From periodic table we can see that palladium has an atomic number 46 and it is present in transition elements. So therefore it is a transition element. In A and B we can see that it is written that its density is similar to the density of sodium. Now sodium belongs to group 1 of the periodic table and the density of transition element is higher than group 1, so therefore this is incorrect. In part C and part D it says it is present in compounds in more than one oxidation state. Now this is a true statement for transition elements because transition elements are found in more than one oxidation states. For example, iron exists in both +2 and +3 oxidation state. Let's look into the property of palladium compounds. Some of them can act as catalysts and they are white in solid state. Now this is true because transition element compounds can be used as catalyst. For example, vanadium pentaoxide is used as catalyst in contact process. And they are white in solid state. This is incorrect because transition metals or transition elements form colored compounds. Correct answer is therefore C. Question 29. 3 different elements react by losing electrons. The ions formed all have electronic configuration 2, 8. Which statement about these elements is correct? Now these elements react by losing electrons. It means that these elements are actually metals because metals react by losing electrons. A, they are in the same group. This is incorrect because after losing electron, the electronic configuration will not be same. It will be different for each element of the group. B, they are in the same period. This could be true statement. For example, if we have sodium, which has 11 electrons, then magnesium, which has 12 electrons, then aluminum, which has 13 electrons. So after loss of electron, the electronic configuration of sodium will be 2,8. For magnesium, again it will be 2,8 because it will lose 2 electrons, and aluminum will lose 3 electrons, so the electronic configuration will be 2,8. So B could be the correct option. C, they are noble gases. This is wrong because they are metals. D, they are transition elements. This is also a wrong statement because transition elements atomic number is quite high, so therefore they will not fit in this electronic configuration after formation of positive ions. Correct answer is therefore B. Question 30. A power cable requires an element that conducts electricity, has relatively low density, and third is that it should be resistant to aerial oxidation. Which of these conditions does aluminum satisfy? Now aluminum belongs to group 3 of the periodic table and it is a metal. Therefore it is good conductor of current, so option 1 is correct for aluminum. Option 2, it has relatively low density. This is also true for aluminum. Option 3, it is resistant to aerial oxidation. This is also true because aluminum forms a layer of aluminum oxide which is resistant to further oxidation and corrosion. As all three options are correct, the answer is therefore A. Question 31. Some atmospheric pollutants are listed. We have sulfur dioxide, methane, nitrogen dioxide, unburnt hydrocarbons. Which substances could be removed by reacting with calcium carbonate? First one is sulfur dioxide. Now sulfur dioxide is a non-metal oxide and it is acidic in nature. It can react with calcium carbonate, aqueous, to form calcium sulfide along with the production of carbon dioxide, and this process is used in flue gas desulfurization. So sulfur dioxide can be removed by using calcium carbonate. Second is methane. Methane is a hydrocarbon whose formula is CH4. It does not react with calcium carbonate, so methane cannot be removed by calcium carbonate. Part 3 is nitrogen dioxide. Nitrogen dioxide is again a non-metal oxide and it is acidic in nature. It can react with calcium carbonate, aqueous, to form calcium nitrate, calcium nitrite, along with carbon dioxide. So nitrogen dioxide can be removed by using calcium carbonate. Part 4 is unburnt hydrocarbons. Again, hydrocarbons are organic compounds and they are non-polar. They do not react with calcium carbonate to form any product. So part 4 is incorrect. As option 1 and 3 are correct, the answer is therefore B. Question 32. River water contains many impurities. Which process alone can produce pure water from river water? Part A is adding chlorine. Now chlorine can be used to kill bacteria that is present in water. It cannot remove any other impurities whether they are soluble or insoluble. So part A is incorrect. Part B is distillation. In distillation we can remove solvent. In this case solvent is water. So water will be removed while all other impurities will be left behind. So part B is correct. Part C is filtration. Filtration can only remove insoluble impurities. It cannot remove soluble impurities and also cannot kill bacteria. D is passing through carbon. Now carbon can remove odors. It cannot remove soluble substances. So therefore this is also wrong. Correct answer is therefore distillation. Question 33. Compound Q is a hydrocarbon that has no isomers. Compound Q does not decolorize bromine in the dark. Which compound could be Q? Let's look into the options. We only have carbon and hydrogen compounds. The first one is C3H6, so it is CnH2n. It means it is alkene. So 3-carbon alkene is called propene. Part B, we have C3H8 and the general formula is CnH2n plus 2. As 3 into 2 equals 6 plus 2 becomes 8. So therefore this is alkane and 3-carbon alkane is called propane. Similarly, C4H8 is alkene as its general formula is CnH2n and 4-carbon alkene is called butene. 4-carbon alkane is butane as its general formula is CnH2n plus 2. Now in the question it says compound Q does not decolorize bromine in the dark. Only alkene can decolorize bromine in the dark. So therefore it is not alkene, it is alkane. So it could be butane or propane. Now let's find out whether which one has isomers and which one does not have isomers. So in propane we have 3 carbon atoms. Rest are the hydrogens. This is the only isomer that is possible for propane. No other isomer is possible. So therefore it could be propane. For butane we have 4 carbon atoms in the long chain. Rest are the hydrogen atoms. We can also draw another isomer of butane in which we have 3 carbon atoms in the long chain and 1 carbon atom is in the form of branched chain. As the formula is same, so therefore this is also isomer. Both have general formula C4H10. So for butane isomer is possible, so therefore butane is incorrect. Correct answer is therefore B, which is propane. Question 34. Which organic compound requires the least number of moles of oxygen for the complete combustion of 1 mole of the compound? Let's write the combustion reaction for each of the following. In A we have 3 carbons, 7 hydrogens and 1 OH. It will combust in the presence of oxygen to form carbon dioxide and water. Now let's balance the number of carbon atoms as we have 3 carbon atoms on the reactant side and 1 on the product side. So we can write 3 with CO2. And we have 7 hydrogen atoms plus 1 hydrogen atom. So in total it becomes 8 hydrogen atoms on the reactant side. So we can write 4 with H2O to make it 8 hydrogens. Now the number of oxygen atoms in product is 6 in CO2 and 4 in water. So 4 and 6 becomes 10. While on the reactant side we have 1 oxygen atom in this compound and 9 should be present over here. So we can write 9 by 2. Now 9 by 2 is equal to 4.5 moles. So for 1 mole of A, we would need 4.5 moles of oxygen for complete combustion. Now doing it for B, we have C3H7. COOH plus oxygen. It forms CO2 and H2O. First, balancing the number of carbon atoms, we have 4 carbon atoms present, so we can write 4 with CO2. Similarly, we have 8 hydrogen atoms present in the reactant, so we can write 4 with H2O to make it 8. The oxygen atoms on product is 8 plus 4, 12. So as we have 2 on this reactant, so we would need 10 with this oxygen. So we can write 5 with O2 to make it 10 oxygen atoms, so in total it will be 12. So we can see that for 1 mole of this compound we would need 5 moles of oxygen. For C we have C3H8. It can also combust in the presence of oxygen to form CO2 and H2O. Now balancing carbon atoms. We have 3 carbons on the reactant side, so we can write 3 with CO2. We have 8 hydrogen atoms in the reactant, so we can write 4 with H2O. Now balancing oxygen. We have 10 oxygen atoms in the product, so we can write 5 with O2. So 1 mole of C3H8 requires 5 moles of oxygen. Now the last one, which is D, we have C4H8. It can combust to form CO2 and H2O. As we have 4 carbon atoms on the reactant side, so we can write 4 with CO2. Similarly, we have 8 hydrogen atoms, so we can write 4 with H2O. Now 8 plus 4, 12 oxygen atoms are present on the product side, so we can write 6 with O2 to make it 12. So for 1 mole of C4H8, we would need 6 moles of oxygen. Now the least number of oxygen is present in first one, so therefore answer is A. Question 35. When a molecule of a saturated hydrocarbon is cracked, it forms 2 molecules X and Y. Which row is correct? Now saturated hydrocarbon means it consists of carbon-carbon single bonds, which is alkane. For alkanes, general formula is CnH2n plus 2. When alkane is cracked, it forms alkene along with the molecule of hydrogen. For example, we have 6 carbon alkane, which is C6H14. It can be cracked to give an alkene of 6 carbon atoms, which is C6H12 along with hydrogen molecule. The number of carbon atoms are same on the reactant and product side. The number of hydrogen atoms is also balanced. As there is no oxygen in saturated hydrocarbon, only carbon and hydrogen are present, so therefore H2O is not possible. Looking at the products, we have alkene and hydrogen. The general formula of alkene is CnH2n, and this is the other product. Correct answer is A. Question 36. The structures and names of 3 alcohols P, Q and R are shown. These are 3 alcohols. The structures may not be named correctly. Which structures are correctly named? In first alcohol, we have this OH functional group and we have 1 carbon atom. So 1 carbon alcohol is called methanol. So P is incorrect as it is named propanol. In Q, we have this OH functional group which is present with 2 carbon atoms. So 2 carbon alcohol is called ethanol. As it is named correct, so Q is correct. In R, we can see that OH is attached with other 3 carbon atoms. So 3 carbon alcohol is called propanol. As the name is incorrect, so R is wrong. Only Q is the one that is named correctly, so therefore answer is C. Question 37. What is the empirical formula of ethanoic acid? Now, ethanoic acid is 2-carbon carboxylic acid, which can be written as this CH3COOH. So in total we have 2 carbons, 4 hydrogen atoms and 2 oxygen atoms. So the empirical formula will be CH2O, as it shows the simplest ratio of atoms in the compound. The answer is therefore A. Question 38. What is the structure of propyl methanoate? Propyl methanoate is ester. It has 2 parts. The first part is propyl, it comes from alcohol. And as it is propyl, it is formed from 3-carbon alcohol, which is propanol. While second part is from carboxylic acid. And as we have methanoate, so it means it is 1-carbon carboxylic acid, which is methanoic acid. The formula of methanoic acid is HCOOH, while the formula of propanol is CH3CH2CH2OH. We have 3 carbon atoms, 1 OH, and in methanoic acid we just have 1 carbon atom. Now when these two react together, what happens that H and OH, they form water, while rest of the compound joins with each other. The product formed is CH3CH2CH2. Then we have this oxygen, then we have this oxygen, then this carbon and this hydrogen. So we can see that we have 3 carbon alcohol and 1 carbon carboxylic acid. The structure is similar in both. The answer is therefore D. Question 39. Which substance on combustion produces oxides of nitrogen? Only that compound will produce nitrogen upon combustion which consists of nitrogen element. So we can see that proteins are made up of amino acids. And amino acids contain nitrogen. So therefore protein is the only substance that upon combustion will produce oxides of nitrogen. Fats, starch and pterylene does not consist of nitrogen, so therefore B is the correct answer. Question 40. The monomer used to manufacture polystyrene is shown. This is the monomer. We have carbon-carbon double bond that is present. By which type of polymerization is polystyrene formed, and what is the possible partial structure of the polymer? In the monomer we can see that double bond is present, so therefore this is alkene, and alkene go polymerization by process called addition polymerization. Now we can draw the polymer in such a way. We have 2 monomers. This is the first one. This is the second one. And so on. Now what will happen is that this double bond is converted into single bond, and 1 bond is formed on this side and 1 bond will be formed by carbon on this side. Again this double bond is converted into single bond. This carbon will make bond between these 2 carbon atoms. This carbon will make further covalent bond with the next carbon atom. So the product formed will be like this. We have first carbon, this one, which will make a new bond on the back side. We have hydrogen, we also have a box. Then on second carbon we have 2 hydrogen atoms. Now double bond is converted into single bond. The new bond formed between these two will be this one. Then we have this carbon atom having hydrogen and box. Then this carbon atom having 2 hydrogen atoms, and double bond has been converted into single bond, and this carbon is making further single bond. In the options we have addition polymerization, which is true for alkene, and condensation polymerization, which is wrong. Now among addition polymerization, we can see that in the product we have alternate boxes on first and third carbon. On first carbon we have a box, then on third carbon we have a box, while in this product we have box on each carbon atom, which is incorrect. This one is similar to the structure that we have formed. Correct answer is therefore B.
Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.